Hello, biology. So we're starting our next chapter, which is titled Classification. And the classification chapter is going to talk about how people began to notice the world around them and began the art, I guess, of trying to put things in their place and put things in, giving them a name. So trying to give every living thing a name. And all of this started way back at 400 BC. So actually quite a long time ago. And I want to make a note that when we talk about this, and Aristotle doing this at 400 BC, this is classic European knowledge or history. I don't know the Middle Eastern or Far Eastern date lines on when these things were discussed there. And perhaps that's something to look up. But in the book and in all of our books, we always sort of refer to these early discoverers as being uniquely European, I suppose. So in this case and our case, we're going to talk about Aristotle and what Aristotle came up with way back then, quite a long time ago, is that there are living things. And probably there were discussions as how could you tell the difference between a living thing and a non-living thing? We call those biotic things and abiotic things. But that's coming up in a future chapter. But Aristotle said, okay, so we've got living things, and he went about the business of trying to classify those living things. And he did it by saying, okay, so the world is made up of plants, which are living. We make those green in honor of chloroplasts. And the world is also filled with animals, which are also living. Whoops. And at this time, those were the two main groups of organization, because there is no doubt that back then there would have been absolutely no way to see anything smaller. So all of our protists, all of the bacteria, all these other living things that we know about now were unknown at that time. So Aristotle sat back and he said, okay, so the world is made up of plants and the world is made up of animals. And he didn't really talk much more about plants, but he went about the business of saying, okay, so animals either have blood or they don't. And so he classified animals into two categories, as either having blood or being bloodless. And of course, this doesn't account for every animal on Earth, but it was all of the animals that Aristotle had ever come across. And then whether they had blood or they were bloodless, they fell into three additional categories, according to Aristotle. And that was either they lived on land, or they lived in the air, or they lived in the water. So you can see that there is, without a doubt, a very simplified version of how to classify all of the living things on Earth. And this stood around and was a classification system that people used for a very, very, very long time. And so you can see that humans have this idea that organizing things or classifying things is, kind of a serious business. Look at this. Beautiful. And we've always done it, at least as far back as our history tells us. We've been trying to put things into boxes or categories for a very, very long time. And so there is a name we actually have, and that name is, the art of classification is called taxonomy. Taxonomy, which is the science of naming and classification. of living things. And in the past, well, if you're Aristotle, you based your taxonomy on these criteria. But in the past, up until recent times, the taxonomy was all based on morphology. I know you're thinking, time out, what does morphology mean? Morphology is a word that means body structures. So it's like when you have a dead body, it goes to the morgue. This more means body. So morphology is the study of body structures or the anatomy of something. So it's based on appearance. And that appearance could be external or it could be internal. Most plants that are flowering plants, at least, are based, or at least these early taxonomy structures, the early classification of these things is based on the structure of their flowers, which is kind of interesting. This is in the past, though. Morphology and classifying things that way there's been something that's happened in the past, and that is today we try to classify things based on their evolution. And but there are some reasons why we would still classify things based on morphology, and that is that it's what you can see. So there's something called a field guide, and we looked at one of those earlier when we looked at the field guide of the mammals that I had out and flipped around through. And I have another field guide. Let me grab it really quick. This field guide is based on flowers and flowering plants that you might see in meadows. And, sorry, it was in the other room. But this field guide is put out by the Audubon Society, and it's looking at flowers. And, you know, honestly, when you're out looking at flowers, you don't know the names of them probably, or, you know, who they're related to. That's not something you necessarily need to know. So what oftentimes in a field guide, things are classified based on shape and color, which is morphology. And so this book here, if you look over here, there's a little guide. If it's a white flower and it has kind of that structure, it's going to fall into these pages. If it's a white flower and it has sort of this structure, you're going to see it on these pages. And that's how you look for things in this particular book, is you're looking to see what the shape of the flower is and the color of the flower is, and then you flip through the pages until you find your flower. And this is, you know, just an example of how you still see things, books and field guides, where plants and animals are separated out just based on appearance, not an evolutionary relationship. So that is still a current thing. So taxonomy either is classifying things based on morphology or on evolutionary relationships. And since we just got finished with our evolution chapter, that's what we're probably like thinking in our mind, especially after doing all those trees, those phylogenetic trees where we looked at how things were related. Okay, so let's come up to, quote, modern times and talk about a guy named Carlos Linnaeus. Linnaeus. Let's see. Linnaeus. Carlos Linnaeus is known as the father of taxonomy. And that would be a modern taxonomy, not based on evolution, but based on morphology. And he created a system of naming and classification that still is around to this day. And his saying, his thing he liked to say is that God creates and Linnaeus classifies. And there were a lot of people during this time who believed very much so that through studying the natural world, through studying in plants and animals and flower structures and all these different things, one could more closely see the heart of God, and that, or a better understanding of what the God's creation was. And so during this time, there was a lot of push in that direction. Linnaeus worked, and people sent him plants and animals from all over the world to be named and classified. So even today, a lot of the names of the plants and the animals that we know of, the known species of living things on Earth, were originally named by Linnaeus, and those names still mostly exist. Some of them have changed as we've discovered evolutionary relationships. One interesting thing about Linnaeus's classification is that he was pretty accurate when it came to putting things together based on just a physical appearance. But they turned out that later, when people started looking at the evolutionary relationships between the organisms, that his classification system also seems to relate pretty accurately with evolution. There are, obvious differences, but over time, his classification system has really stood the test of time, as it were. Okay, so Linnaeus was a pretty powerful figure, and his classification is based on a system of classification. Oops, L there. And we still use this system today. And so I'm going to flip over the page, and we're going to draw a pyramid. And the pyramid is going to, if we were in class, we'd probably build a pyramid. But we're not, so we won't. But at the top of the pyramid, and maybe I'll do the pyramid secondary just so that I can make it the right size. So you can follow this along. Every living thing that is independent is going to be a member of a species. So this is a really specific identification of an organism. And there's an F in there somewhere, specific. And below that is a group of species that all fit into the same section. That's going to be called the genus. There's a bump on my table that made that happen. Genus. And if you take the genus of organisms and group them together into a larger group, those would be called the families. I'm going to give you an example as soon as we're done. I'm not sure how I'm going to show you that example, though, unless you're looking at the lecture. I did attach the lecture, and we'll talk about that. After the families, organisms can be put into orders and class, phyla, and kingdom. We're going to see that the kingdom system has changed a little bit over the years. So let's take and use for an example a rose. Like you realize there's lots of different types of roses. And we could say there's a specific rose like moss rose. And so that's one species that has homologous chromosomes that match up, and it's a rose. You could probably order it online, have it delivered to your house. And it's a specific individual species. But that species is part of a genus, and that genus is going to include all the different varieties of roses. So let's say that's a moss rose, and all the different varieties of roses, things we think of as roses, like in a rose garden, are going to be the genus. But we should know that there is an entire family of, goodness gracious, that has like 3,500 different species of roses. And the family is going to include lots of shrubs and bushes and plants that all are classified in the Rosaceae. And that includes like almonds and thinking of other roses, almonds and pears and nectarines. There are a ton of fruit plants that are in the Rosaceae. So this is a family identification. And so this is a wide variety of plants that's flower type is rose-like. And then the order is the Rosalis. So that's going to be a bunch of other different plants that also fall into this. And at the class level, gosh, I don't even know. I know that they're the flowering plants. This is the plant kingdom. Plant kingdom, the phyla is going to be the angiosperms. A class is probably seed plants. And the order, I'm not sure what the order is, but you can see that each of these builds on each other. If we look at the plant kingdom, that's going to include every single plant on earth. And once we look at the phyla, we're looking at everything that puts out a flower. And then we have a bunch of different divisions, monocots, dicots, all this stuff that's happening in between that. Okay, so if you want to have some fun, you could color this pyramid. I know. I could use some fun. La 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 la. Whoops, whoops, whoops. This pencil is wigging out. I guess the next example of this classification system is in the lecture notes. I kind of just like peeked forward at it. And it has to do with birds. So if you look at the lecture notes, you can see that the species that is being put out is the Blackburnian warbler. And you know, I bet if I put my screen like this, you can see, look at that. That's the lecture note. So there's the warbler. It's a single species, but we also know that it is part of a group of warblers, and that group of warblers is part of all the wood warblers, and all the wood warblers in the world fall into the songbird category. And all the songbirds and all of the raptors and all of the waders and all of the woodpeckers and sapsuckers, they all fall into the class of birds. And then birds is one of the many phyla that fall into the classification Chordata, which is what our phyla is. It's anything that has a backbone. So you can think, this picture shows you've got the tigers and, well, not just tigers, but all mammals, and you've got all birds and all reptiles and all amphibians and all fish, everything that has a backbone. And then again, the kingdom would be Animalia, and that includes all animals, that whether they have backbones or not. And so that's all the insects and all the worms and mollusks in the ocean and stuff like that. So this classification system was created by was created by Linnaeus, and it's still used today. And as it turns out, this classification system is highly accurate, both morphologically and evolutionarily. And yeah, so it's really stood the test of time. Okay. Linnaeus also, his other big contribution to classification or taxonomy is something called binomial nomenclature. Binomial nomenclature means that there are two words. This is like scientific names. And I'm sure you've heard them before, but there are two names for every one species. So a species is identified by two names. There is the genus and the species identifier. So by two names. So for instance, humans, we all know that's not our scientific name. Our scientific name is Homo sapien. And we should know that Homo is our genus and sapiens is our species identifier. I have got to get a drink of water. Hang on. And this is supposed to be lowercase. I'm sorry. And that's kind of a rule, is that the first word is capitalized and the second word is lowercase. And we call that binomial nomenclature. So when we look at a book that has the species and name of different plants or animals, we'll see that those books all have scientific names. So I brought this one over. This is a field guide to Western birds. And if you pop it open, you could, let's find a favorite bird. I am kind of a fan of owls. So the owls themselves, those are hawks, these are owls. You can see that their scientific names are going to start out with a capitalized, and this is in italics usually if it's typed. So Strix is the genus of the barred owl. There's a barred owl right there. And its species identifier is Varia. And this would indicate a very specific owl. If you look down here at the great gray owl, it's Strix nebulosa. So Strix is its genus and Nebulosa is going to be its species identifier. And you can see the snowy owl is part of a different genus, and the barn owl, Tyto, is a different genus. And we've got other genuses here: Otis, ACO, Bubo. So, oh, that's cute. The great horned owl, which we are hearing a lot this time of year because it's their mating season. The great horned owl, the Bubo virginaeus, is a its name. It's part of the genus Bubo, and its species identifier is virginaeus. Probably saying that really, really wrong. Yeah, I don't see any other Bubos, at least not in this book. Which is interesting because, you know, it's the member of its only member of its genus. But I guess I haven't talked so much in so long. All right. So this binomial nomenclature, either way, was developed by Linnaeus, and it helps us identify exact species of organisms. And that's not going to include some of the wacky species that we talked about back in evolution. Of course, none of those things were known back when Linnaeus was doing his work. Okay, so modern taxonomy is based on looking at genetics.